Okay, now let's check when S is equal to 1 and I is equal to 0. If S is equal to 1, then this 1 would go through these wires to the gates of M2 and M3, also through this wire to the gates of M1 and M4 in this block as well. So if I is equal to 0, then through this wire we have 0. Since you see it is connected to the gates of all of the transistors, we have 4 zeros. Zeros at the gates of M1 and M2 would cause this wire to go high through M1 and M2 path. So we have a 1 here. This one would go to the gates of M1 and M4 as well. We have 4 ones on the gates of all of these transistors in this block, causing this wire to go to the ground through M3 and M4. So we have a 0 here. This 0 would go to the gates of M1 and M4 as well, causing the wire of out2 to go to VDD through the M1 path. If we have 1 here, this 1 would go through this wire to the gates of M4 and M1 as well. I was 0, right? This 0 would go to the gates of M2 and M3, causing this wire to go to the VDD through M2 path. We have 1 here, which is the gate of M2 and M3. We have 4 ones on the gates of all of the transistors in this block, causing out 1 to go to the ground through M3 and M4 path. So you see, when S is equal to 1, if I is equal to 0, it doesn't matter what the previous value of out is. The out would definitely be equal to 0. Now let's check the other case, when S is equal to 1 and I also is equal to 1. So in this case, again, we have 1 at the S, which would cause this wire to have 1 at M2 and M3, and also we have 1 at the M1 and M4 as well through these wires. Now, if I is equal to 1, through this wire, we have 1 on the gates of M1 through M4 in this block, causing this wire to go to the ground through M3 and M4 path. As we said, 1 at the gates of NMOS would cause the NMOS to be turned on, acting as a short circuit. So we have a 0 here. This 0 would go to the gates of M1 and also M4. 1 0 is enough at the gate of the PMOS to be turned on, and therefore this wire would go through the VDD using the M1 path. So we have a 1 here. This 1 would go to the gates of M1 and M4 as well. The other effects of I equal to 1 is that we would have 1 at the M2 and M3 in the first block, causing this wire to go to the ground through M3 and M4 path, since the gate is equal to the high voltage. So we have a 0 at this wire. This 0 is at the gates of M2 and M3, causing 1 0 at the gates of any one of these PMOSs would be enough for this wire to go through the VDD using the M2 path. So in this way, out 1 would be equal to 1. So when S is equal to 1, then out would be equal to, when I is equal to 1, out would be equal to 1. So what we could say is that when S is equal to 0, it doesn't matter what I is, out would always remember its previous value. And when S is equal to 1, then out would always follow the I. If I is equal to 0, the out would be 0. If I is equal to 1, out would be equal to 1. Therefore, we could create an abstraction in this way. We say we have a, we have 2 inputs and 1 output. I call this a 1-bit memory. Why? Let me just name it, or let me actually put I say I have an input and 1 output and a bit called S bit. If S bit is equal to 0, out would always remember its previous value. If S is equal to 1, then whatever we put at the I would be shown on the output. So what we could say is that we could also call the S like the enable bit, that if it is equal to 1, we could write to the 1-bit register that we have by putting our favorite value on the I on the input, because when S is equal to 1, but whatever is at the input I would be shown on the output, and when S is equal to 0, the output remember its previous state, ignoring whatever however or whatever the I changes. So we created a 1-bit memory. In the next lecture, we are going to expand our register to an 8-bit register and add other pins for the clock and other things as well.